In this tutorial, we're going to show how to connect Ignition to a Modbus TCP IP device. We're going to set up tags in Ignition to read the Modbus registers in the device, and we'll finish with displaying live tag values on an Ignition perspective HMI screen. To complete this tutorial, we're going to use SimServe by Scatomatic to simulate the Modbus device. SimServe has been installed on a separate computer that's connected to the same network as Ignition to make the example as realistic as possible. Now we'll go over to the computer that SimServe is installed on. We'll launch the web interface to SimServe. For our tutorial, we just need a single Modbus TCP IP device, so let's create it now. Let's name it Device 1. For the protocol, we'll select Modbus TCP. For simplicity, we want to assign Device 1 to have all IP addresses of the computer it's installed on, which is accomplished by entering 0.0.0.0 into the IP address field. This means the device can be reached by the computer IP. We'll leave the Modbus port at default 502. Sometimes the bit, byte, or word order of the computer SimServe is installed on is different than the computer Ignition is installed on. If this is the case, adjust the necessary orders. This is uncommon for most applications. Now we'll click Save and observe that the device was created. Let's open the device now to see the registers. Now that we've simulated the Modbus TCP IP device, let's jump over to Ignition and set up the connection to this device. I'm just going to switch to the Ignition server now. Now that we're on the Ignition server, let's start off by creating a connection to the Modbus device on SimServe. This is done in the OPC UA module. Click on Device Connections. Click on Create New Device. We'll select Modbus TCP IP device and click Next. We'll set the name to Device 1 to keep the name the same in Ignition and SimServe. We'll set the description to Test Device. We'll make sure the connection is enabled. For the hostname, we'll enter the IP address of the computer that is running SimServe. We'll enter the same port that the Modbus device is using in SimServe, which is 502. All other fields can remain as default, and we'll go ahead and click Create New Device. After the device is created, we'll notice it appears in the table. The most important thing to verify before moving on is that the status column shows connected. If it doesn't show as connected, we know there is an error in the SimServe setup, the network connection between the two computers, or an error in the Ignition device connection settings. Now that the device connection has been created, we can create some Ignition tags in the HMI designer and link the tags to graphics. In preparation for the tutorial, a page has already been created with graphics on it. We only need to create the tags and link to existing graphics. We'll start out by creating a tag that's linked to coil register 1 in the Modbus device. The tag will communicate to the Modbus device through the OPC server, so let's create an OPC tag. We'll name the tag Tag1. We'll set the tag data type to Boolean because a coil register is only 1 bit in size. We'll set the tag's OPC server to Ignition. Then, we'll enter the OPC item path, which needs some explanation. We need to use special syntax that tells the tag to look into device 1 and read coil register at address 1. Device 1 is written in brackets, followed by the register type, which is C for coil, and the address, which is 1. Later on, we'll be showing the creation of several other tags which refer to different Modbus register types and have different data types to teach the syntax. Now that the tag has been created, take a look at the value column and you'll see a checkbox checked. That's telling us the value for the tag is 1. If we go over to SimServe and change the register value to be 0, you'll then see that the checkbox is unchecked. Now we'll quickly link this tag to an existing graphic. We'll save and open runtime. If we view the value, we'll notice it's currently 0. If we go to SimServe and change the register value to 1, we then see a value of 1 in the HMI. Now we'll repeat this process for tags pointed to different registers and data types. In the Ignition Designer, we'll create a second tag called tag2. We'll keep the settings the same as before, but this time we'll read discrete input register 1 and set the OPC item path as shown. Device 1, followed by DI for discrete input, followed by 1 for address 1. We'll link the tag to graphics now and view in the HMI again. Now we'll go to SimServe, navigate to discrete input 1, toggle the bit, and see it update in the HMI. Moving on to tag 3, which we pointed to analog input register 1 as an unsigned 16-bit integer. Take note that the OPC item path is now device 1, followed by IR for input register, followed by US for unsigned short, followed by 1 for address 1. Let's link the tag to graphics and view it in the HMI. Let's go back to SimServe, navigate to analog input register 1, and enter a unique value. Then we'll check the HMI to make sure it was properly updated. Moving on to tag 4, which will be pointed to analog input register 2 as an unsigned 32-bit integer. The OPC item path for that will be device 1, followed by IR for input register, followed by UI for unsigned integer, followed by 2 for address 2. Now we're linking the tag to graphics and we'll view the current value in the HMI. Let's navigate to SimServe and change the value of the associated register like we did before. However, this time, rather than changing the register value directly, we'll create a tag in SimServe that's pointed at the register and change the value via the tag. We're going to do it this way because a 32-bit unsigned integer spans 2 Modbus registers, and it requires some math to determine the appropriate value for each register to display a desired value in the HMI. Creating a tag in SimServe instead lets SimServe handle the math for you. Go to the Tags tab. Click Add Tag, then enter the name of tag 4, set the data type to uint32, the starting address to 3x2, and leave the initial value as 0. Enter a unique number for tag 4. Before we check the HMI, take a quick look at the Register tab again. You'll notice that 123456 was entered for the tag value. However, Register 2 is 1 and Register 3 is 57920. This is the conversion process that SimServe is handling for us. Now if we check the HMI, we'll see a value of 123456. Now we'll make tag 5, which we pointed to analog input register 4 as a 32-bit float. The OPC item path is device 1, followed by IR for input register, followed by F for float, followed by 4 for address 4. We'll link the tag to graphics and view the current value in the HMI. We'll then navigate to SimServe, create tag 5 in SimServe, and assign a unique value. We see the HMI shows the correct value. Let's create tag 6, which will be pointed to holding register 1 as a 16-bit signed integer. The OPC item path is device 1, followed by HR for holding register, followed by 1 for address 1. We'll link the tag to graphics and view the current value in the HMI. Now we'll navigate to SimServe, create tag 6 in SimServe, and set a unique value. We see again that the value appears correctly in the HMI. Let's create tag 7, which will be pointed at holding register 2 as a signed 32-bit integer. The OPC item path will be device 1, followed by HR for holding register, followed by I for integer, followed by 2 for address 2. Again, we link the tag to graphics and view the current value in the HMI. Then we navigate to SimServe, create tag 7, and set a unique value. We view the HMI and confirm the correct value is displayed for tag 7. Last, we're going to make tag 8. We'll point tag 8 to holding register 4 as a 64-bit float. The OPC item path is device 1, followed by HR for holding register, followed by D for double, followed by 4 for address 4. We link the tag to graphics and view the current value in the HMI again. We then navigate to SimServe, create tag 8, and set a unique value. We verify the value appears correctly in the HMI. So that's the process. That's how tags in Ignition can be linked to Modbus registers in an external device. I know it was a lengthy video, but hopefully eliminates some headaches for you in future integration work. Lastly, as the tutorial shows, SimServe is a great tool to help work through Ignition to Modbus integration challenges, and I recommend checking it out. Thank you for watching, and please reach out to us at support@skatamatic.com if you have any questions we can assist with.